Hey guys, today we're going to wrap up the second part of weather, and the way we're going to end it, we're going to be looking at something called synoptic weather maps. So when constructing a weather map, what we look for is these little station models. So you can see as we go across the country that you have these little circles, and then around those circles you have a bunch of numbers. Some of those circles are shaded in. They have bars extending off of them with something called feathers. So when looking at station models, here's how we're going to work it. I want you to turn to page 13 in your reference table, and you're going to see this chart here. And this explains what a station model is. The reason why we use these station models on that map I just showed you across the country, there's a lot going on. So at every single airport or certain locations in each state across the nation, we want to send up what's called weather balloons. As those balloons go into the air, they're going to take readings about the weather at the present time and then report all of that on the map. A synopsis is a brief summary. So that's why we call these synoptic weather maps. These station models are kind of like a summary of all the weather that's going on at a certain time. And you get a lot of information in a very small space. We need to save space on the weather maps to get the most information on our weather map. That's why we use these station models. So you need to know how to read a station model. And once you know how to read it, you're going to be able to tell me a bunch of things, which we'll go over today in our video. So first things first, let's just go through this again. Like I said, these are our station models on page 13 of the reference table, and they measure different variables like temperature, which you'll see up here. We'll also be able to measure the air pressure. That's the most difficult thing. We'll get to that after. The precipitation, whether something is falling from the sky, which you'll see in this present weather chart, which is also slightly below on your reference table, this chart right here, and other conditions, which we'll look at. So one thing to know also, most weather systems move from west to east. So we'll normally look maybe at the weather in Chicago. And normally the weather in Chicago, about a day, maybe 2 days later, will move across from west to east and hit us about a day or two later. And like I said, these maps provide information used not only at the present time, but also to make predictions. So let's break this down. Take a look here, and what you want to look at is you're going to always start with a circle. And that circle, what it's going to tell you is a bunch of stuff. So first thing I look at is how much of the circle is shaded in. Now again, you have this on your reference table to do all your questions when you get questions on station models. So if they were to ask you how much of the sky is covered in clouds, how much cloud cover, we're going to express that in percentages. What you want to look at is how much of the circle is shaded in. And you could see here that we have right there, this whole area here, 75% of the circle is shaded in. So if they were to ask you on this station model how much cloud cover there is, you would say 75% cloud cover. So I would call that a mostly cloudy sky. Next up, the temperature. And you can see the temperature is measured in degrees Fahrenheit. Here, if they ask you for temperature, you're going to look, and you can see in the upper left corner the number 28. Right now, at the present time, it's 28 degrees Fahrenheit at this location. The next thing we'll look at is down here, the lower left. That is the dew point. And the dew point here is 27 degrees Fahrenheit. So one thing you could figure out already, the temperature and the dew point. If we go back just last week, we said the closer the temperature is to the dew point, the more likely you are to get precipitation, something falling from the sky. Look, sandwiched in between the temperature and the dew point, there's a symbol here. That symbol represents the present weather, what's happening right now. If there was nothing here, then there would be no precipitation falling, and it would probably be just a very, calm day. But there is a symbol here. So what you got to do on your reference table is look for the present weather chart, which is just below this station model explanation. And then you're going to look at the symbol, and I see that star here. That star tells me that right now it is snowing at this weather station. Okay, and you got to figure that too. The temperature is below 32 degrees Fahrenheit, which is the freezing point. So if anything's falling from the sky, it's going to fall either in the form of ice or snow. So that's one way to tell whether you're likely to get precipitation. When comparing station models, you'll compare the temperature to the dew point. And another thing to note, when the temperature is close to the dew point, not only are you more likely to get precipitation, you are also probably going to have a higher relative humidity, okay? Because the more humid it is out, the more likely you are to get rain or snow. Right next to the present weather, you see a fraction here. Now, this doesn't have to be a fraction. It could be a whole number. This number, again, also sandwiched in between the temperature and the dew point, that tells you the visibility in miles. That means if you're standing at this weather station and you're looking straight out, how far you could see straight out. On a clear day, this number might be 10 miles, but it's snowing out. So when snow is falling, you're going to have a very low visibility. At the station, we could only see 1/2 of a mile. Also, I do want to go back to the present weather. Here are the other symbols and what they stand for. So you're not always going to get snow there. If you had this little circle with a comma, that would be drizzle. Just your standard little dot, that would be rain. This is something called smog. The triangle is hail. This is thunderstorms, rain showers. I could keep going on and on. But one thing to note, fog and haze, those do not fall from the sky. Smog also. They do not fall from the sky. We would call that condensation. Everything else on here is precipitation because it falls from the sky. All right, next thing to look at on our station model, you see a bar coming off of the circle. That bar, you're going to look at it, and it tells you where the wind is coming from. So in this case, you can see the bar is coming from the south part of this circle and west. So we would call this a southwesterly wind, and it's where the wind is coming from. So our wind is coming from the southwest, and if it's coming from the southwest, it's actually blowing to the northeast. All right, and coming off of that bar are something we call feathers. And this will tell you the speed of the wind. So we have a southwest wind coming from the southwest, and then here it tells you a whole feather is 10 knots, a half feather is 5 knots. So this is a whole feather, that's a half feather. What you do is you look at the feathers and you add them up to figure out what the wind speed is. And most of the time, they'll ask you in knots. In fact, all of the times, pretty much in our multiple choice questions, they will ask you what is the wind speed in knots. So here we have a wind from the southwest. Let's add up the feathers. One whole feather is 10 knots, and a half feather is 5 knots. Add them up, and our total wind speed is 15 knots. Okay? Barometric pressure. They give you a 3-digit number here on the station model. The real barometric pressure is a much larger number. I'm going to get to that in a few minutes. And the barometric trend we'll get to in a few minutes as well. The only other number I'm going to talk to right now is precipitation. This number on the lower right part of the station model, here it is a decimal, 0.25. It doesn't necessarily have to be a decimal if you have a lot of rain, but this tells you how much has fallen in the past 6 hours. So at this location, they've had 1/4 of an inch of liquid precipitation. That means it's falling as snow. So 0.25 would really come out to about 3 inches of snow. Okay, so let's do a couple of questions that we've already can do. I didn't go over pressure yet, so we'll do that soon. Let's start with question number 1. The weather station model shown below indicates that winds are coming from So again, I'm going to look for that feather, and you can see that feather if you were to draw your little compass, right? I'm doing the best I can, but there's my compass, and that's north, that's south, that is east, and that is west. We see that our wind is coming from that direction, which is southeast. So it's got to be southeast. So choice A is a possibility, not choice B, not choice D. Now, the difference between A and C is the wind speed. Let's take a look at the feathers. Now remember, a whole feather is 10 knots. We're going to add up the feathers. This is 10, that's 10, 10 plus 10 is 20. There is the correct answer. Okay, number 2. Which station model represents a location that is currently receiving some form of precipitation? So there are 2 ways to look at this. First off, we could already eliminate choice B. Look, there's no cloud cover. Okay, so choice B, not even possibility. Next, choice A, choice D, and choice C. They do all have the little weather symbols. The other thing you'll notice, the temperature and the dew point are close together. So there is a possibility that all 3 of these could have something falling from the sky. But here's the key thing. We want to look at the weather symbols. And whoops, I did not put the weather symbols in here, but take a look at your reference table right now. This, I believe, off the top of my head, is haze. This, I forget what that is, but I do know that this is, like, I believe, a rain shower or something. This is your answer. It's falling from the sky. It has to be something falling from the sky. Okay? The other 2, fog, haze, and smog that we talked about, those are forms of condensation. Next up, let's go to question 3. All right, I'm just trying to show you all the ways to do this. Which weather station model indicates the greatest probability of precipitation? Now, they didn't give you any present weather symbols here. So when they ask you for the greatest possibility of precipitation, again, you're going to compare the temperature and the dew point. The closer they are together, the more likely you are to get some kind of precipitation falling from the sky. So 24 is your temperature in A, 16 is your dew point. That's a difference of 8. In B, the temperature is 24, the dew point is 20. That's a difference of 4. In C, 24 and 23, that's only a difference of 1. And in D, 24 and 18, that's a difference of 6. So the most probable precipitation, the greatest probability, is going to be where the temperature and the dew point are close together, choice C. Not only that, if they could change this question, say what is the station with the highest relative humidity, that would also be choice C. When the temperature and the dew point are close together, you also have the highest humidity. All right, and then on the other end, the least probability of precipitation would be where they're furthest apart. That would be choice A. But in this case, they're asking for the greatest probability, choice C. Now, at which weather station is visibility the greatest? Again, visibility is that little number sandwiched in between temperature and precipitation. So this here, choice A, is a 5-mile visibility. That's greater than choice B, which is only a half mile, and you could tell because it has that symbol. There's something going on in the sky, so it's definitely not choice B. Right now, A is greater than B for visibility. Let's compare the visibility now, A to C. C is only 2 miles, A is 5 miles, so far A is winning. And then D actually has a 9-mile visibility. That would be the greatest visibility because it's greater than 5. Therefore, D is the answer. Okay, moving along. Let's do the toughest thing, and that is air pressure. So air pressure on our station models, we abbreviate. We abbreviate because, again, we use these station models to save space on the weather map. So if you take a look, the normal air pressure at this station that is given to you on your reference table is 1019.6. Count the digits. That's 5 digits and a decimal point. That would take up a lot of space on a whole map of the United States because we have a lot of station models. We are looking to save as much space. So what we do is we have to kind of decode this number and transfer it to the station model. Or maybe they give you the station model and you have to decode it and give me the actual pressure. So air pressure numbers are abbreviated to save space. So how do we do it? Well, if we were to look to go from the regular air pressure and convert it so it is on the station model, it's really simple. Your air pressure will always start with either a 10 or a 9 in front because it's going to be either in the low 1000s or the high 900s. So this is 1019.6 millibars. The way we abbreviate to save space. So if they tell you the air pressure and say which station model shows this air pressure, what you got to do, you're going to take off either the 10 or the 9 in the front, and you're going to take the decimal and just move it out. Now you're left with 196 because we moved that decimal out. And look at the number on our station model, 196. Okay, so just to give you a few examples, let's say the real air pressure here is 1017.6. Again, what we need to do, we need to get rid of the 10, move the decimal out. And on our station model, it would look like 176. Okay, this one, again, now it's 966.3. Like I told you, there's always a 10 or a 9 in front. You take the 10 or the 9 out, move the decimal over, and on the station model, it would look like 663. So forth, 410, I take the 10 out, move the decimal over. In this case, I take the 9 out, move the decimal out, I'm left with 892. So this is what it would look like on the station model, always a 3-digit number. Moving forward, what if we were given a number on the station model and we wanted to find the real air pressure? What we would have to do then is we look at the first digit. So let's say we have a station model and it looks like this. All right, there's my station model. It says 253 as my air pressure. So they're going to want the real air pressure, the real barometric air pressure. You're going to look at the first digit from the station model. And here's the rule. If the first digit is less than 5, so 0, 1, 2, 3, 4, the first digit, what you do is you add a 10 to the number and you put a decimal point before the last number. So it would be 1025.3. Now, what if the first digit is 5, 6, 7, 8, or 9? Then what you would do, again, look at the first digit. This is 5 or higher, right? 5, 6, 7, 8, or 9. And what you do now, instead of adding a 10 in front, you add a 9 in front. And then put a decimal point before the last digit. So this would be 955.3. Okay? And that is our rule. So just working with that, I always say, look at this as a cheat sheet. All right, because it is. You get this on your test if you were in school, and right now you are not in school, so it's in front of you anyhow. But what you would do, again, look at the chart on page 13. Look at the first digit here. It's less than 5. Notice what they put in front. They tell you the real. They put a 10 in front. And look over here, my first example. First digit is less than 5. Therefore, a 10 goes in front, decimal before the last number. First digit here is 5 or higher. Now I put a 9 in front and a decimal. Here it's less than 5. I put a 10 in front and a decimal. And that would give me the real air pressures. Okay, so you could see what it becomes. This one, it's higher than 5. Rule is put a 9 in front and a decimal. And here it's less than 5. I put a 10 in front and a decimal. That's how we convert our air pressures from the station model to real life. Okay, so let's do some questions here. Question number 1, which weather station model shows an air pressure of 993.4 millibars? So remember the rule. When you want to go from the bigger number to the shorter number, we're going to take out here. So I'm going to take out the 9 or 10 in front, move the decimal out, and I'm left with 934. 934. There's your answer. A weather station model is shown below, 0 to 9. Well, this, the first number here, I'm going to rewrite it, 0 to 9. And again, we look at the first digit. If it's less than 5, we add a 10 in front and a decimal before the last digit. 1002.9, there's my answer. And lastly, which station model correctly represents the weather conditions in an area that is experiencing winds from the northeast at 25 knots and has had a steady drop in barometric pressure of 2.7 millibars during the last 3 hours? So I haven't gone over this yet. This is called the barometric trend, all right? A drop in pressure, 2.7 millibars during the last 3 hours. So first things first, they told us we had a wind from the northeast at 25 knots. Let's eliminate some answers here. Choice A, the bar is coming from the northeast. We have 2 whole feathers, that's 20, plus 5, that's 25 knots. So far A looks okay. B, same thing. For the wind, looks good. Northeast, 25 knots. C is from the southwest. Okay, so that's not right. And D, the wind is coming from the southwest. Not right. Okay, so we're left with A and B. Now let's get to the barometric pressure trend, right? We have a drop in pressure of 2.7 millibars. Look up here. Again, this is on your reference table, page 13. This is the barometric trend. It's underneath where you have the pressure on your station model. The first thing, you'll see either a plus or a minus sign. If it's a plus sign, that's telling you the pressure has been going up or rising in the past 3 hours. If it's a minus, that would mean it had a steady drop in the past 3 hours, or it has been going down. The other thing is this. This says plus 19. Notice what it says in the parentheses, 1.9 millibars. So when they give you this 2-digit number here, to figure out how much the barometer, the pressure, went up or down, you are going to simply just put a little decimal in between those two numbers. 19 becomes 1.9. So this tells you plus, rising, 1.9 in the past 3 hours. In our question, they said a drop of 2.7. So the number on the station model should be on the right-hand side of the circle, and 2.7 would look like 27. And it's dropping, so it should be negative. And it looks like choice B has your negative 2.7 millibar drop. There's your answer. Okay, so that's that. So lastly, let's just wrap it up with a part 2 question. And let's see how we do on that. Base your answer to questions 1 through 4 on the 4 weather station models A, B, C, and D below. List the letters of the 4 station models in order from the station with the highest air pressure reading to the station with the lowest air pressure reading. So the first thing I would do, I would convert these pressures. And what I would find is this. A, I'm going to convert this pressure, 0, 1, 2. What I do for something like this, I rewrite the air pressure. The rule is, look at the first digit. If it's lower than 5, add a 10 in front. Whoops. 10 in front, and a decimal before the last digit. So this is 1001.2 millibars. Now this is a funny one. Watch this. Not that it's really funny, but 9, 9, 9. Doing the best I can. The rule is, look at the first digit. If it's 5 or higher, we add a 9 in front and a decimal before the last digit. That's 999.9. I'm going to rewrite this one. That's 9. I'm getting a little bit better at my drawing here, right? 978. Rule is, if it's higher than 5, add a 9 in front, a decimal before the last digit. That's 997.8. And then I'm going to rewrite this one, 0, 0, 2. Rule is, if it's less than 5, add a 10 in front and put a decimal, 1,000.2 millibars. So they said from the highest in order to the lowest. So the highest air pressure out of all three is A, right? Then the next highest is D. Then B is the next highest. And out of all these, C is the lowest. All right. What evidence indicates that station C has the highest relative humidity? Remember, I said compare the temperature to the dew point. The closer they are together, that would indicate a higher humidity and also a higher likelihood of precipitation falling from the sky. And you could clearly see this is a 20-degree difference. That is not even close. That is a 7-degree difference. So right now B is better than A. C is only a 3-degree difference. And look, it's completely cloudy also. And D is an 8-degree difference. So easily I could see that C has the greatest likelihood of precipitation and also the highest humidity because the temperature and the precipitation are closest together. All right. And lastly, on the station model D above, draw the proper symbol to indicate a 25-knot wind coming from the west. How would I do it? First things first, I would draw my bar. I would draw my bar from the west. That indicates the wind direction from the west. And then a 25 knot. Remember, the feathers, you have to add them up. A whole feather is 10 knots. So I'm going to need 2 whole feathers and another half feather. That's 10 plus 10, that's 20. And then another half feather is 5. All right, long video, but I want to make sure you understand how to use our station models.